Welcome back to the deep dive. We're here to take a complex source material and really boil it down to what you need to know, quickly. Today, we're putting on our security orchestration, automation, and response SO engineering hats. We're going to dig into the core knowledge needed for these platforms, and our source is, well, a bit different today. We're using the XSOAR Engineer certification outline as our guide, the mission, to pull out those absolute must-know points for a solid SO setup, thinking infrastructure, data handling, the whole nine yards.
Yeah, and what's really interesting is how a technical certification like this actually maps directly to the big priorities in a real-world SOC. It's not just about code. It highlights, I think, three main things: keeping the lights on with resilience, making sure your data is trustworthy, and executing processes in a really structured way. Get these core ideas, these 5 points we'll cover. You pretty much understand how successful SOFL platforms actually work day to day.
Okay, sounds good. Let's tackle these like an engineer would, starting with the absolute foundation, keeping the system running no matter what. So, picture this. You've got a busy 20/47 security operations center. Automation's churning through thousands of alerts. Incident response cannot afford to stop. What's the key architectural thing you need, the setup required to make sure that if your main XO server or maybe just one part of it fails, that incident handling just keeps going?
Wait, this is really fundamental. It shapes the whole design.
Yeah.
What you need isn't just, a simple backup plan. It's a high availability cluster, an HA cluster.
Okay, high availability.
Exactly. HA provides that operational resilience. But for SO, why you need it is almost more important than what it is. It means you've got multiple servers, multiple nodes configured, so if one goes down, another just takes over automatically. But this is critical. It's about state replication. Think about it. An incident playbook could be halfway done. Maybe it's collected evidence, set some variables, started logging for compliance. If that server fails right then, and the backup node doesn't know exactly where things stood, you haven't just lost a server.
You've lost the investigation context.
Precisely. You've lost evidence, time, maybe even failed compliance. HA ensures that the entire investigative context transfers instantly, mid-action.
Ah, that's a crucial difference. It's not just mirroring the setup, it's mirroring the active state of investigations. Okay, job one, stable infrastructure. Got it. But even with a rock-solid platform, it's useless without good data, right? So let's move on to how data gets into the system, ingestion.
Exactly. Automation totally depends on getting predictable data in the right fields.
So you get these raw alerts flying in from all over: SIEMs, firewalls, EDR tools, you name it. The data's kind of messy, unstructured from the SARA platform's perspective. How does the platform figure out, okay, what kind of alert is this? And then how does it take the details from the alert and put them into the right standardized fields inside XR?
Yeah, you need a way to manage that sort of input chaos. It takes two specific components working together to get that classification and field population right. You need a classifier and a mapper.
Classifier and mapper, okay.
Think of the classifier as like the first gatekeeper. It looks at the raw incoming data and decides the incident type. Based on rules you set up, it figures out, okay, this looks like a potential malware incident, or maybe this is a phishing attempt. That's the first cut.
And the mapper then tackles the messy part of different tools, calling the same thing by different names. That whole schema problem.
That's exactly right. The mapper is where the real standardization magic happens. You might get data from 10 different security tools. One calls the source IP source heap. Another calls it circuit error. Maybe a third uses attacker rep. They all mean the same thing. The mapper takes that specific piece of data from the source alert, whatever it's called, and makes sure it lands in the one standardized source.ip field, or whatever you've defined, inside XSOAR.
Ah, okay.
If you don't get that mapping right, every single playbook or script downstream has to somehow know about all 10 variations. It completely breaks scalability.
That makes total sense. Unify the data schema right at the door. Okay, so we've got data classified and mapped internally. But what about data coming from outside? External threat intel feeds, for instance. Their quality can vary a lot. So if an engineer adds a new threat intelligence feed, how do they manage its trustworthiness? How do you prevent the system from, say, automatically blocking a critical IP based on flaky data from an unproven source?
Right. This brings us to assessing the trust level of your inputs. And that's, well, it's absolutely vital for safe and effective automation. You manage this inherent variability using the source reliability score.
Source reliability score.
Yeah, it's a setting you configure when you first integrate that feed. Let's say you add a brand new feed. Maybe you're not sure about its accuracy yet. You give it a lower reliability score. Now, when the platform sees an indicator, like a suspicious IP from this new feed, that score affects how it's evaluated. especially if that indicator conflicts with information from another feed, one you've maybe used for years and assigned a very high score.
So the platform can weigh the evidence.
Exactly. The decision-making logic inside the platform can be set up to say, okay, I have conflicting info. Prioritize the indicator from the source with the higher reliability score.
Hmm.
This way, you make sure that automated actions, especially risky ones like blocking IPs or quarantining devices, are driven by intelligence you actually trust. It helps minimize those dreaded false positives.
Okay, so infrastructure stable, internal data is structured, external data is weighted by trust. Now let's get into the nitty-gritty inside a running playbook, where the automation logic lives. Let's say task A runs, maybe it queries an external API like virus total or something, and it gets back this huge chunk of data, like a complex JSON object, nested fields, lists, dictionaries, the works. But task B, the next step, only needs one tiny piece of that. Maybe just a single IP address buried 3 levels deep in that structure. How does the engineer pluck just that one specific piece out cleanly?
Yeah, you definitely need tools for that kind of precision work, for manipulating data between the steps of a playbook. The feature set you're looking for here involves filters and transformers.
Filters and transformers.
Filters let the engineer apply very specific logic. Often you use query languages like JSON path or maybe regular expressions to dive into that complex output from task A. They let you basically zoom in and grab only the relevant bits, like pulling out that one specific IP address from deep inside the JSON.
Okay, so the filter narrows it down. What does the transformer do?
The transformer then takes that extracted piece of data and, if necessary, changes its format or structure. So let's say the filter pulled the IP out, but it was part of a list, maybe 1.2.3.4. But task B expects just a plain string, 1.2.3.4. The transformer handles that conversion. It ensures that the data flows correctly from one task to the next in the exact format needed, no matter how messy the original output was. It's about making the data digestible for the next step.
That sounds like where a lot of the detailed engineering work happens, making sure data shapes match up between tasks.
Okay, now let's shift gears slightly. We talked a lot about reacting to incidents, but SOCs also have routine, recurring tasks. For example, maybe an analyst needs a report every single morning. Something simple like list all the high-severity incidents created in the last 24 hours. It's predictable, needs doing every day. What automates that kind of thing? It's not triggered by an alert, it's triggered by, well, the clock.
That's a great distinction. You're moving from reactive automation to proactive, scheduled automation. And the feature designed exactly for this is the scheduled job.
Scheduled job. Makes sense. Yeah, it lets you set up automation routines to run on a fixed schedule. Like you said, every morning at 7 a.m. or maybe every Friday evening or the first day of every month. Generating reports is a classic use case, absolutely. But you can also use scheduled jobs for things like system maintenance, maybe clearing out old indicators, archiving old incidents, or running routine health checks on integrations. It neatly separates the automation triggered by an incoming alert from the automation triggered by time. And it takes a huge load of repetitive manual work off the analyst's plates.
Based on what we discussed today, we talked about how XSOAR uses a specific source reliability score to manage the trustworthiness of external threat feeds. So think about this. What other areas in your own security operations could maybe benefit from some kind of defined reliability score? Could you apply it to vulnerability scan results, perhaps? Or maybe even the initial priority given to an internally generated ticket? Should certain inputs automatically carry less weight if the source hasn't been historically accurate? Something to consider. We'll see you next time for the next deep dive.